So we're going to move on now to the session 2 and the second panel. And the topic we're looking at is reducing operational costs of corporations and major data centers through renewable energy and storage technologies. I would like to invite the lead speaker, Dr. Ayotunde Coker, Managing Director and Chief Executive Officer, RAC Center. Moderating will be Adejoke Adekunle, CEO, VVM Group. And the panelists in this round will be John Kikenda, Director of Software, Analytics and Customer Support, PowerGen Renewable Energy. Professor Eike Weber, Chair, European Solar Council, ESMC, and former Director, Fraunhofer ISE in Freiburg. And then we have Stefan Rajaonarivo, Principal, Global Industry Lead, Energy, and Regional Lead, West and Central Africa at the IFC. Please welcome you all, and I'd like to pass this on to Adejoke Adekunle. Joke, to you, please. Thank you.
All right, thank you, Stephanie, for the introduction. Good morning, everyone, wherever you are right now. This is the second session, second panel on the Renewable ReEnergy Africa eSummit. I am privileged to be here. I would quickly have us, we are kind of running out of time. We have about 40 minutes for this session. So jump into the session with our lead speaker, Dr. Ayotunde Coker. But before that, I would really like for the panelists to quickly do an introduction of themselves. Stephanie has provided some context about them. It would be useful for us to hear from them a bit of background, starting with John Kikenda, and then we'll move on to Professor Eike, and then we move on to Stefan, and then we lastly, Dr. Ayotunde, where he will take on the lead part of this, the leading part of this session. So over to you, John. Please do a quick introduction of yourself and welcome to this panel, to this session.
Thank you. As been mentioned, my name is John Kikenda. I lead the technology and customer teams at PowerGen Renewable Energy. PowerGen is a distributed energy utility / mini-grid developer based in Nairobi, Kenya. We operate in 5 countries at the moment, Kenya, Tanzania, Sierra Leone, Nigeria, and just starting up in Benin, serving about 15,000 households, about 50,000 customers with power through mini-grids that we develop and operate. We've been in operation as a company for about 11 years and excited to be part of this panel. Thank you.
All right, thank you very much, John. Next now we'll have Professor Eike Weber. Professor Eike,
very much. Very briefly, I have been at UC Berkeley as the Professor of Material Science from 1983 to 2006, and then I joined Fraunhofer ISE in Freiburg, one of the the world's leading research institutes in solar and renewable energy. And after 1.5 years in Singapore, I'm now back in Berlin, and I act as chair of the European Solar Manufacturing Council. In addition, I am as well involved in a startup company called Enteria, which is busy to set up solar systems in Germany and Africa, and we have very interesting projects there. And the topic of bringing renewable energy to Africa, to all the people who have not access to electricity, is for me very important. So I'm very happy to be part of the panel today.
Great. Thank you very much for that quick introduction. I will move over now to Stefan Rajaonarivo. You're welcome.
Thank you. So yes, I work with IFC. IFC is one of the institutions of the World Bank Group, and IFC's mission is to support the development of the private sector in its member countries. It is an institution owned by 183 countries. And IFC is well known for its investment activities, but we also have an advisory branch. So I work with the advisory part of IFC, and I focus on sovereign advisory activities. We provide advisory services to governments, any sovereign entities that are developing and structuring projects that involve private sector participation, either through expertise provision or financing or both. Yeah. Thank you.
Great. Thank you very much. And finally, we have Dr. Ayotunde Koka. He'll do a quick introduction of himself, and then we'll just quickly dive into the to his speech, which would take about 10 minutes or 7 minutes, and then we'll move on to the discussion in detail.
Good day, everybody, ladies and gentlemen. It's a real honor to be here, to be talking on this subject. Very quickly, I'm the MDC of RAC Center. RAC Center is the leading carrier-neutral data center provider in West Africa. We've been operating since October 2013 with 100% uptime. We've been growing since then. We're a household name in West Africa now and in Africa, and also a globally recognized brand, unprecedented for the data center companies. We've won a whole series of international awards. About me, I was born in Nigeria. I went to university, and after about 30 years, almost 30 years in the UK with international roles, I came back to Nigeria about 12 years ago as Group CIO of Access Bank. At the time, they were expanding and growing in Nigeria, one of the top banks in Africa now. I was MDCO for emerging markets payments for West Africa and West Central Africa. And I've been MD of RAC Center, building this brand and the company since, for just over 6 years now, since 2014. So very quickly, without much ado, I've put this together as an element of context to talk about a variety of things. The digital infrastructure in Africa in a contextual view. There's a dependency model around data center infrastructure coming straight down to energy. There's some global initiatives and other initiatives that we're working on at RAC Center. I understand the issues of time, so please pardon me if I rattle through this very, very quickly. And I've almost already spoken for 2 minutes. So if you look at the population of Africa, it's around about 17% of world population. GDP is 4% of world population. And what I call that the prosperity gap. It's a gap we need to fill, and we have an opportunity to do that in time. But if you look at data center infrastructure, we're only 1% of data center infrastructure in comparison to the world. So that's the digital gap, and other aspects of digital enablement that are not subject of this discussion. So how do we fill that digital gap? A data center is it's a huge piece of, it's at different scales, but it's a piece of infrastructure that hosts critical IT systems. It has to be up 100% uptime, highly connected, so it allows customers to connect to their systems, connect to the world, and telcos, and so on. They operate at great power demands. These IT systems require lots of cooling, and also must operate at specific temperatures and humidity. They underpin the digital infrastructure. So this digital infrastructure is underpinned by the data centers, broadband penetration, which is essential for addressing this digital gap. And high quality multi-tenant data centers really drive efficiencies, rather than having lots of little data centers all over the place where you can't have a view on the quality and hence uptime, or actually the eco-efficiency of the data center. They tend to be not capital efficient and not efficient in terms of running. So highly efficient, more centralized multi-tenant data centers tend to be able to handle that in the middle. And it's in power intense, as I mentioned, but COVID-19 has shown the immense positive impact of digital infrastructure in the world. The world infrastructure has really been able to scale up significantly. And as you've seen, lots, because people don't have to travel so much, people don't have to travel to work in traffic, a lot more efficiency. We've seen a lot of improvements in air quality right across the world. And there's another thing with fiber and digital infrastructure for connectivity. It's been proven that 10% fiber penetration actually gives up to 2.5% GDP growth impact. So combine these, it's key infrastructure that helps us to bridge that digital gap and the prosperity gap in Africa. There's a natural dependency also for infrastructure. If you look at the energy, absolutely is essential for this. The data center depends on that. There's in all of these stacks here, there's a dependency. And of course, around that, you need the people, processes, and controls. Why would you want data centers in Africa, not in Norway or somewhere that's much cooler? Because in Africa, we have, in Nigeria anyway, or the equatorial Africa, we have what I call the 90-90 challenge, 90 degrees Fahrenheit, 90% humidity. Is a concept of latency. You know, increasingly you need the digital infrastructure closer to the point of use. And if Africa is going to leverage new emerging technologies as artificial intelligence, real-time operations, and so on, we need to have the digital technologies closer to the point of use. There's something actually in this energy and data center part of this that talks about power usage effectiveness. So it's total facility power and input IT equipment power. So the best you can get is 1. The lower your number, the better it is. So the less power you need to put in to run these IT systems, the better it is for the fact that you don't need that much power. You know, it's very dense, and it's good to see some of the improvements that we've had in renewable energy. The dense power means that if you bring in renewable energy, if your PUE is a lot better, then the benefits you get, even when it comes to power replacement, the better it is. And the digital infrastructure in the networks, you have subsea cables, broadband enterprise networks there. The cloud enterprise infrastructure, for instance, and business applications that are in the cloud. So these things pull together to give us infrastructure that we require to bridge that digital gap, as I mentioned. There have been global initiatives as well. The iMasons is it's an international sort of group of infrastructure executives. It's an independent forum to connect and give back, and they have these sort of initiatives, 5 initiatives around sustainability. And the term that's used here is every click improves the future. I've shown this. I can't go through this as I initially thought, to indicate the thought processes around delivering cost-effective solutions, around renewables, around data set efficiency, cost-efficient, energy efficient, and sustainable energy. And I was part of a team that discussed sustainability. Every click improves the future for EMEA. And if you look at some of the trends here, we're talking about, leaving a good legacy, something to be proud of. How do we close the prosperity gap, grow digital technology in Africa and in EMEA? This was what I was talking about. We have a young population in Africa absolutely geared towards digital enablement. And we've been doing some things with the IFC as well, this EDGE initiative, to reduce greenhouse gases emissions. We're looking at a benchmark of PUE, for instance, and this is a pilot that we're working on with them that says we will work as an example of highly resource efficient data center infrastructure as we build this infrastructure out in Africa. The thesis really is that because we're in Africa doesn't mean we shouldn't have the sustainability. In RAC Center, we've done everything at world class. We're Tier 3 certified. It's at one of the highest levels of data center quality certifications you can have. And we can grow the digital infrastructure by ensuring that we also can be passionate about sustainability in the process. Thank you very much. I'm very much looking forward to the insightful discussions that we can have on the panel here, and wish everybody all the best. Thank you.
Thank you very much, Dr. Ayatunde. That was a very quick presentation and also very insightful. I would like to learn more about the IFC partnership. Can you expand a bit on that?
Yes, it's an initiative by the IFC, really quite an innovative initiative that's looking at the power utilization effectiveness, power usage effectiveness. And for different climes, you can actually benchmark what the baseline should be, and then assess digital infrastructure data centers against performance to that baseline, given the climes that they are. So if you're 3,000 meters above sea level, very light humidity, for instance, there's a baseline, which might be, say, PUE of 1.5 or 2. Generally, normal efficiency, PUE efficiency in the world has actually been improving over the years. I didn't mention that in the presentation for speed. We've had PUEs of 2.5 from about 2006 as an average, indicated by the Uptime Institute. Uptime Institute is a global body for data center technology, infrastructure, quality assessment, to around about 1.65 in 2012, and now it's around about 1.58. That's a global average. As you know, averages can mislead. You do have very high PUE to 2.5 data centers, and some are very efficient to 1.2 PUE. So in being able to baseline, it therefore is a referential point in terms of the sustainability, the baseline sustainability performance for a data center. And the reason we're working to be a lead in that innovation is that we're really committed to ensuring that we provide leading efficiency in the data center infrastructure that we build, and have it indisputably assessed as right practice, leading practice, whatever time we choose to use in sustainability here.
Okay, great. I will come back to you later on in the panel. I'd like to talk about the cost benefits for data centers as far as this project goes. But I would like us to now move over to our panelists. Again, the topic for this panel, or for this session generally, is, the short version is money. Long version is reducing operational costs for corporations and large data centers through renewable energy and storage technologies. Now, I will go over quickly to John Kidenda. You work with PowerGen, which is as you said, a major renewable energy company. And I would like to understand a few things from a finance standpoint. Now, if you look at mini grid projects, for example, that companies like PowerGen is involved in, one of the challenges that mini grids usually have is productive use of electricity. And then, of course, load capacity, where you're able to quickly recoup some of your investments. But then we see that that's not like a challenge with the corporate sector. You're going to have productive use of electricity. You're going to have high consumption of electricity as well. And then the chances that you recoup your investments in the corporate sector is much higher. How significant would you say is the adoption of renewable energy in the corporate sector compared to households and then off-grid communities?
Thanks, Adijoke. It's a good question, and the answer is that it is steadily ramping up and growing a lot faster than a lot of us, even in the industry, anticipated, and for a number of reasons. As I think it was mentioned in the initial presentation, it's not simply enough to make the case that on a kilowatt to kilowatt basis, it's cheaper to build renewable distributed infrastructure for a private or a corporate client. There's this ecosystem of supporting infrastructure that needs to be in place for a project to move forward. And that ecosystem includes the right type of financiers who are willing to take a risk on developing this type of project. It includes the right type of regulation that will enable the entity to capture the benefits of deploying renewable energy. And it also involves having examples that people can point to of successful deployment of these projects, so that it, in the minds of potential customers, is de-risked from the perspective that it has been successfully done before. And as we have more and more examples of these across the various countries that work in Nigeria, in Kenya, and as potential customers see these, and as we use these as examples to point to, it's increasingly becoming easier to make the case for a corporate client. As you mentioned, the demand problem goes away when you're working with an industrial client, which is a major challenge on the mini-grid energy access side of things. These are people who have more demand than they know what to do with. And importantly, oftentimes we're looking at industries where it's not simply a matter of demand, but people who are very sensitive to the question of uptime that was just mentioned by the lead speaker. Downtime of a few minutes to a few hours can result in very significant economic losses. And so providing both cost-efficient power, but more importantly, reliable power in the environments where the grid is notorious for being unstable, makes it increasingly easier to make the case to corporate clients. And therefore, you're starting to see sort of like a snowball effect with the deployment of more and more commercial and industrial renewable energy projects.
Okay, I have two follow-on questions from that. The first is, what are some of the pricing innovations that companies like PowerGen has explored for the corporate sector? You mentioned the bit about financing to be there has to be good financial incentive. So what are some of the innovations around pricing that have been explored?
Yeah, so innovative financing solutions is one of the things that we like to think we're known for bringing to the table when working with partners. We've developed partnerships with a number of entities. One that I can mention, for instance, is a company called Cross Boundary that's also based in Kenya, that we often partner with to work on the financing side of things. So Cross Boundary has managed to deploy a number of private sector PPAs with commercial and industrial clients, which means that the customer does not have to foot the entire bill of deploying the asset at the beginning of the project, but signs essentially a purchase agreement with the private entity, in a similar way that the government would have a PPA with an independent power producer, and the private business is therefore able to spread the cost of the project across a much longer time horizon, which makes it easier to get to project close. Additionally, partnering with various funders that are interested in the sector, including entities like that, like the IMF, for instance, that are able to crowd in concessionary financing from international funding institutions that reduces the cost of capital of these projects, makes it easier to get to project close. And then finally, maybe I'd also include our willingness to come in as equity partners in some of these projects in order to reduce the amount of debt that would need to be brought into the project, especially if you're looking at commercial level debt. I think one more thing that I would mention in terms of financial innovation, one thing that we're really proud of is we structured in conjunction with Cross Boundary what I think is the first special purpose vehicle for mini-grid projects. So this is more on the energy access side of things, but this is essentially a vehicle into which we were able to bring in third-party investors and sell our grids that we had built on our own balance sheet into, with the revenue from the energy sales going to the investors in the special purpose vehicle. What this does, it enables us to recycle our capital, and it enables us to build more projects, which eventually just results in us being able to deploy more in the future.
Okay, thank you. I'm glad to hear, some of the initiatives that PowerGen is exploring around that. I would now move over to Stefan. Stefan, please, quickly, I want to know, what are some of the IFC-funded initiatives or affiliate projects that corporations can tap into in Nigeria specifically for increased energy access and then farm productivity?
I guess the first thing I would say is that the challenge of developing data centers in Africa is very much a relevant issue for governments. Many of them want to expand and go into ICT and see data centers develop on the continent. We need to understand why it is extremely challenging. So if we just focus on sub-Saharan Africa, because that's where the cases are most obvious. Out of about 50 utilities in sub-Saharan Africa, only 2 to date collect sufficient cash to cover cost of service. This basically means that in terms of ability to invest and sustain their operations, meet the demand, provide reliable electricity, it's virtually impossible to meet the needs of data centers in those countries. So we really need to think out of the box. And another challenge that government has, so the average access to electricity in Africa, in sub-Saharan Africa, is 47%, so 50% less than global average. So if you're thinking, and we try to mobilize funds and channel those funds to ensure the development of data centers, for governments, it's a touchy question, right? Because half of the population is asking for electricity, but we are finding solutions for big corporates. And I'm not saying it's a bad thing or a good thing. I'm just saying it's challenging. And this is also challenging from a technical standpoint for utilities, because it's not just a generation problem. It's a generation problem, a transport problem, it's a distribution problem. So the whole chain is affected, and it makes the challenge of providing electricity to data centers and to businesses in general very, very challenging. So what are we doing? So we're trying to develop legal and regulatory frameworks that allows for creative solutions to develop. For instance, in some countries, we're trying to open the generation market so that companies can develop their own generation capacity to meet their needs. And in many cases, we're seeing that happening right now. We're seeing that happening in the mining sector. We're seeing it happening in some of the for data centers and some other industries. That's one option. Another option is to develop a contractual mechanism that involves the utilities and IPPs and the data centers of the mining companies, and through a tripartite agreement, get the corporate entity to get the electricity it needs, the reliable electricity it needs. Those are the kind of mechanism and financial structure that we're working on right now.
Great. I can understand, some of the challenges that you highlighted. What are the things that within the IFC's control in, navigating some of these barriers that they have with getting more businesses connected?
IFC is a very demand-driven institution. So most of the time we react when our clients call upon us and tell us, okay, we have this problem and help us solve it, be those corporate clients or sovereign clients. We're also trying to think ahead and be more proactive. We're currently developing a number of initiatives. We call them upstream initiatives, where we work with government and corporate entities to try to identify the issues and try to develop solutions with them all together. It would be difficult to pinpoint specific mechanism we're currently working on for data centers.
Okay, copy that. Okay, so now we'll come back to you, Mr. Stefan. Thank you so much. I will quickly go over to Professor Aiki. Professor Aiki, welcome.
Hello.
Yeah, so I have a question around, trying to pick some learnings. You've spent, a lot of time, most of your work is focused on the European continent. So I would like for us to, pick some learnings from you on significant energy trends on the European continent that contributed to its industrial resilience. Can you expand on that?
Well, I think there's a very interesting myth which we should debunk. And this is the myth that if we start to rely on fluctuating renewables, we endanger the stability of the power supply. Because the sun doesn't shine in the night and the wind doesn't blow all the time. But what we have experienced in Germany is that with the increasing penetration of our electricity supply from renewables, the grid operators were forced to substantially change the grid, digitalize it, make it automatic. And the consequence is that today our grid in Germany is more stable than it has been before. In 2006, we had an average interruption duration each year of 26 minutes. Today, it is 12 minutes, whereas a country like France with their nuclear power plants, it's 55 minutes. And honestly, I don't want to know what are society index for countries in Africa. I think if we go to our topic of data centers, for data centers, the stability and reliability of power supplies is, of course, of utmost importance. And therefore, I think, honestly speaking, for data centers, it makes most sense to develop as part of the investment cost of building up a data center to immediately develop the own independent and renewables-based power supply, to have a PV system on the roof, to have a battery system for storage, to have a hydrogen supply, hydrogen storage for long-term storage, because you might have a storm which covers the sky for a week in a row. And in this way, you can create a power supply which is basically 99.9% reliable. And this is, of course, exactly what these data centers mean. So I think we should look at it in a different paradigm. For data centers, the renewables is the better technological solution. It's not an issue of reducing the CO2 footprint, which we are all concerned about, but it is really the best possible solution. And our experience in Germany has shown exactly this, because for renewables, you don't need to worry about the supply of diesel oil to come in time and not get interrupted through strikes, breakdowns of the transport system, and the sun shines reliably, even if you have enough storage to cover a week of lack of sunshine, no problem at all. This is all technically doable. And in addition, a data center is, of course, a high value investment. So the amount of investment in a data center is a lot for the hardware. And therefore, to develop this together with a reliable renewable grid-based energy supply, this is the absolutely right thing to do. And I think in this way, you can as well solve the financing issue, because when you already spend so much money to develop a data center, then just include as well the money of the power supply. It is very cost effective because you get independent of purchasing fuels later down the road if you would operate it on diesel generators. And therefore, down the road, it is even a money-saving type of approach. So data centers could be a landmark, and maybe if one oversizes the power supply, then one can as well have a mini grid around it, supplying power to the neighborhoods where these data centers are being built, and then have another positive impact. Down the road, Europe is on the very good way. Germany is now approaching 50% of the electricity supply from renewables. But of course, in Africa, we still have a lot to be done. And of course, for Africa, the decentralized nature of renewables, you know, that you put a wind tower or you put a solar system and you generate the power right where you need it, is of course a big advantage, because the grid is relatively weak, and therefore having decentralized systems which have stable power supply because of their own storage systems, this is actually not only financially, but as well technologically for the people who need the power, the best way to go.
That sounds very, very interesting. I mean, it sounds great, and I appreciate you really enlightening us on that. But what are some of the challenges data centers need to look out for in, transitioning towards renewable energy?
Well,
I don't want to believe it's all a smooth sail. So you just shed some light on that.
I think it's relatively easy. A data center, the main ingredient, it needs stable power supply around the clock and 360 days a year, you know. And therefore, for an operator of a data center who has to worry about fluctuations of the grid, then they put in emergency power supplies, but the emergency power supplies have to be able to work in the moment when the grid breaks down. And we have seen many emergency power supplies who just fail when they are needed. So this is a completely different story. Whereas if you, from the beginning, design the data center to rely on its own renewable energy, and the sun doesn't go on strike, so it really will be available at almost all days of the year, this is a much more reliable solution, which needs much more attention down the road. It doesn't need logistics, you know, worrying about fuel transport and so on. So from my perspective, I think it is a no-brainer to say you should not build a data center without immediately supplying it with its own renewable power supply system. Of course, in some countries, as we just heard it from John, there might be regulatory issues. You know, it has to be permitted, but I think if a power supply system is completely grid independent, the government cannot really do much about it, because, you know, you're just on an island of your own. And today's possibilities, today's relatively low-cost battery storage at $100, $200 per kilowatt hour of storage, today's quite well-developed hydrogen technology, which is quickly increasing in importance in Europe right now, is a story of green hydrogen you have heard about. So hydrogen technology offers a way to store almost unlimited amount of electricity for use whenever it is needed. You can get a very, very stable, secure, predictable power supply. And I think this is the main ingredient what data centers want, because any off time costs a lot of money immediately.
Yeah. Thank you. I have one question, but for both Dr. Ayatunde and then John Kinenda. You both have, more context on the Nigerian business environment, right? As in response to Professor Ike's comments on, that they're not, it's a no-brainer, we agree, but then what contextual challenges do you see with this?
Okay, who goes first?
Dr. Ayatunde, you go first.
Okay, I think Professor Ike hit the nail on the head in the need for absolutely sustained, reliable power. as I put in that dependency diagram, the energy is at the hub of it, then the data center. If your energy is down, your data center is down. If your data center is down, your ecosystem is down. Either if you're a business, a telco, or whatever, it's down. So you have to secure your power. And he's also right that you also have to have enough reliable backup power that can support your entire facility. And that's usually diesel driven, actually, all over the world. Okay. So the key thing is to make sure that your primary power is as sustained and reliable as possible, and cost efficient as possible. And that sustained reliability, continuity, is always it's a challenge in many utility grid areas, not just in Africa, and also some parts of Europe. I mean, there was a point where a line of power supply providers went down in the UK, and all the data centers along the line went down. And then I think I might be referring to it. They fired up their backup systems. I mean, in Africa, we used to have backup systems coming in, and they then fell over and systems went down. And this was really quite a few years ago. So the securing, if it's gas, if it's a special type of an IPP, or if it's a captive power and stuff like that, that variety of options, secure your primary power. Now, one of the key things we make sure is I talked about that PUE, just to get efficiency, because the more efficient you are, the less power you need to drive your outcomes in the data center. And I used to think, because of the denseness of the power, we're talking megawatts and megawatts and megawatts, right? And you would think, well, is renewables actually relevant here, or is sustainability relevant here? And in time, I've actually really come to the conclusion that it is, because it's the relevance in the way you think, either as a chief executive or a chief engineer, is it drives you to innovate and find out all of those solutions that you can to actually drive sustainability. And one of the things I showed earlier with the industry globally is that in the cycle of things, COVID has actually demonstrated that digitization is good for the environment in the whole equation. Mm-hmm. It still doesn't mean that you shouldn't still look at how you can tackle another primary source of energy use to make it as efficient as possible and as sustainable as possible. So I started to realize actually that you don't need to power a 10 megawatt data center with 10 megawatts of fully sustainable power. If you're actually able to achieve 10% of that in a total cost approach, actually that is even neutral, right? There's a sustainable aspect of that. If you really look at how you innovate to say, if I could substitute 10%, I could actually benefit if I could reduce my primary power costs. So that is it. You chip away, and every click improves the future. You keep chipping away at how you continue to innovate and improve the future. And as you scale, and you have surface area opportunities you have for solar, for instance, and you start to get, you don't have to do all of it yourself. You may well find that you're tapping into other energy sources. As you do that, you continue to seek the best balance in what you do to have primary power that is as sustainable as possible. What you usually find is that if you fail over to diesel, actually the impact of the renewables that you're having is much higher, okay, because you can tackle the costs much quicker. I see Professor Ike nodding on that. And that's what we're seeing. So it becomes a quest over a cycle time for you to achieve the right balance. And in time, perhaps we'll be able to do it 100%. Who knows?
Okay, great. John?
Yeah, sure. Echoing both teams, I think the challenges as you have asked for, I think mirror what we see in renewable development in general. Professor Ike mentioned the myth around grid stability. That speaks directly to what I mentioned about people wanting to see it done before they do it themselves, right? Because Professor Ike mentioned that they're at 50% in Germany. I can remember when people were saying if you have 16% renewables on your grid, everything's going to fall apart. The end of the world is coming, right? And then it was 20%. Then it was 20. Like you were, but I don't really get frustrated about such things because it was never going to be, 50% from the get-go. This is just a process of continuously proving the skeptics wrong. And as Dr. Coco mentioned, chipping away at every next barrier that's put in front of you by being able to demonstrate in the real world, not in some theoretical paper, that this actually works. Because the theory, it may be 100% correct. In fact, it probably is 100% correct. But when it comes time to people putting down their money for the construction, people don't want to be the person who bet on the theory and got it wrong. And so I think more deployment just leads to this snowball effect. I think one of my favorite commentators on the development of renewables speaks about this concept of deployment-led innovation, right? The biggest engine for innovation in the renewable sector is more deployment. This is why nobody could have ever told you that you would be having 3-4 cent solar power in 2020 if you asked the top experts in the renewable sector even 5 years ago, right? Deployment always outstrips any sort of imagined technological revolution that is coming down the pipeline. So that's one thing. We will just have to chip away at this by proving the minute one data center manager sees their competitor who has 20% renewables on them, beating them on cost and stability, they will have to explain why they're not doing. Right now, they have to explain why they're doing, which is a much more difficult proposition to have. And then second, business model innovation. If we can, as developers, can find ways to de-risk that deployment from a financial point of view, so that Dr. Coker can have a cost-neutral way of moving in this direction, then he has fewer arguments to make to his board or to his financiers about why this is the right direction to move into. So if we can innovate on the business model side of things with things like private sector PPAs and bring in concessional financing and the like, and if we can prove and build confidence by deploying in a modular fashion, increasing amounts of renewables onto data centers, we will get to a place where anybody who's not doing it is going to have a case to answer, and that's really, I think, the only way that we get there.
Fantastic. I think we had more time. Yeah.
Yes,
okay.
We are, and I'm sorry I have to make a bit of a hard stop. Thank you so much to the panelists. Thank you to Adejoke for the wonderful moderation, to all the inputs. For additional questions, I hope even after the whole summit, some of us will stay behind and also just kind of interact a little bit more and have further conversations around all these wonderful topics that we're talking about.